Alright, in this section we talk about all the different derivative rules that we've learned so far. There's technically 8 of them. The 9th and 10 are a combination of 2 different rules. So the first rule is that if you've got a function that equals some constant number like 14, the derivative is 0. If you got some variable to a power, you just bring the power out front and subtract 1 from the exponent. If you've got a number out in front, the number out in front stays there, but then you take the derivative of what's left and you bring the 3 out front and subtract 1 from the 3, and the 3 times the 5 combined to give you 15. When you've got 2 different things that are being added or subtracted, you take the derivative of each one separately. So that's a 6x and that's a 4. Product rule, a little more complicated. When you got 2 things that are multiplied together, like this guy times this guy, it's the first times the derivative of the second, plus the second times the derivative of the first. So you got the first, untouched, derivative of the second is 1, plus the second, untouched, times the derivative of the first, 2x. Quotient rule, that's bottom derivative of the top minus top derivative of the bottom over the bottom squared. So you got the bottom times derivative of the top, 3x squared, minus the top, x cubed, times derivative of the bottom, 2x, all over the bottom squared. Chain rule. Okay, so you bring the 10 out front and leave the inside untouched, subtract 1 from the exponent, followed by the derivative of what's inside. Alright. Power rule is power rule and quotient rule. So power rule would mean you bring the 3 out front and subtract 1 from the 3, but then you have to take the derivative of what's inside, and that invokes the quotient rule. Product rule, then power rule. So you've got 2 things that are multiplied together. So you got the first guy times derivative of the second, plus the second guy times derivative of the first. Well, the first is untouched. Derivative of the second, bring the 1/2 out front and subtract 1 from the exponent. But since you've got a function inside there, you've got to take the derivative of that. Now the second function is just this guy to the 1/2. It's unchanged even though it's a rewrite. Times derivative of the first, which is just 1. Here you've got the quotient rule, and within the quotient rule you're using the power rule. So the quotient rule says bottom, derivative of the top, and when you do that you got to take derivative of the outside and then the inside using the chain rule, minus the top untouched times derivative of the bottom, which is 1, all over the bottom squared. Alright, so they talk about the use of the power rule in some function like this, but we have not found derivatives of the function like this where you've got something to a power and inside that you've got a product. So you've got a product of 2 functions raised to the 5th power. So we need to use the power rule, then the product rule. And we've talked about that in previous examples. For this one, you've got 2 things that are multiplied, so you're using the product rule, but within that, when you take derivative of this guy, you're using the power rule. So first derivative of the second plus second derivative of the first, and when you take derivative of this guy, it's just derivative of each term. But when you take derivative of this guy, you got to use the power rule. Bring the 5 out front, or the chain rule. Bring the 5 out front, subtract 1 from the exponent, followed by the derivative of what's inside. With this one, when you take the derivative, you bring the 5 out front, subtract 1, it's 4. Leave the inside untouched, followed by the derivative of what's inside, which invokes the quotient rule. This one, when you take the derivative of this guy, you're using the quotient rule. So you got the bottom times the derivative of the top minus the top derivative of the bottom over the bottom squared. But when you take the derivative of this guy, you use the chain rule. 2 out front, subtract 1, followed by the derivative of that, which is just 1. And when you take derivative of this, you're also using the chain rule. Bring the 3 out front, subtract 1 from the exponent, untouched inside, followed by the derivative of what's inside. That's all over the same thing, squared. Now when you go to simplify this, you want to be a little careful when you do that. You want to look at these 2 larger terms and look at them and see how they compare. Well, this one has an x to the 4th plus 3, but it's got 3 of them. It's got x to the 4th plus 3, and it's got 2 of them. So between these 2, they got at least 2 of those, right? So you can pull 2 of those out. And what about x minus 1? You got an x minus 1 there, but you got an x minus 1 twice there. So they both have at least an x minus 1. So you can pull out an x minus 1 out of each one. So that's what I do. I pull out one x minus 1 and 2 of the x to the 4th plus 3's. So for this first part, we pull out 2 of these, and we still have 1 left. We pull out the x minus 1, so that's gone. And you still have the 2. So you have the 2 and the x to the 4th plus 3. Now here, we're pulling out 1 of these, so you still have 1 left. The 3 is still there. We take out 2 of these, so they're both pulled out. And you still have that 4x to the 3rd. So you get the 3, the 4x to the 3rd, and 1 of these. So 4x to the 3rd times 3 is 12x to the 3rd, and you still have one of those x minus 1's. Now when you take what's inside here, this third set of parentheses, and multiply it out, you can combine like terms. But you can also cancel 2 of these with 2 of these in the denominator. So these 2 are gone, and this 6 changes to a 4. And this final part reduces down as far as it can go. So when you simplify, you want to look at the top 2 larger terms and pull out what you can out of both. And then what's left, you put in a big parentheses and combine and simplify as best you can. A lot of times something on top and bottom will cancel, and then you get what you get at the very end there. Alright, so this one, f times, f is this guy times this guy. It's a product rule, but you're going to use the chain rule as well. So you got the first times root of the second plus second times root of the first. And the root of this guy is 1/2 times that to the negative 1/2 times the derivative of what's inside. And this guy's derivative is just 2x. Right? Now when you've got this guy, you can, your 1/2 and your 2 cancel, but you still have the negative sign there. And you have the x, so negative x. And you still have the x squared minus 1. But this guy with a negative exponent is going to cross the fraction bar and make it positive 1/2. And this, you write the 2x out front, and that part doesn't change. Now if you want to, you can write this as one larger fraction. But what you want to do here is think of this as a fraction with a denominator of 1, and this one has this denominator. So you got to make this one have the same denominator, so you multiply top and bottom by whatever you need. Okay? And so when you do that, this first part doesn't change. The second part, you still have the 2x there. But when you multiply this guy times itself to the 1/2, you basically are adding the exponents. Just like if you were adding x to the 1/2 times x to the 1/2 is x to the 2/2, or x. Well, this is to the 1/2 to the 1/2, and when you add the exponents, you get an exponent of 1. Right? And so this guy simplifies dramatically. And now you can distribute your x, distribute your 2x, and combine like terms. And this guy surprisingly does simplify somewhat nicely down to this here. That's about as far as you can go with it, simplifying wise. Example 4, they give you the revenue function. They ask you to find the marginal revenue and then plug in 50 to find when what the marginal revenue is when 50 units are sold. So you're going to use the quotient rule, and you're going to have to use the chain rule when you take the derivative of the denominator. So you got the bottom unchanged times derivative of the top minus the top times derivative of the bottom all over the bottom squared. Derivative of the top is just 36 million. Derivative of this guy is 2 times that to the first times derivative of what's inside, which is a 2. And so you get this guy here. Now, if you look at both these guys, they both have a 36 million that you can pull out. This one has a 2x plus 500 to the second, and this has the 2x plus 500 to the first. So you can pull out at least one of these out of both of these larger terms. So you pull out a 36 million and one of these, pull out a 36 million and this, and you're left with just 4x for that term, and you're left with this guy just by itself. So now when you combine these two, you get 500 minus 2x, and when you can cancel one of these with the denominator, making that 4 in the denominator, making it a 3, and that's about as far as you can go with that. So now you plug in a 50, simplify it, and you get down to $66.66. That is the predicted revenue from the sale of the 51st, because we plugged in 50. This is the revenue from the 51st unit, which is approximately $66.67. So now we're doing a bunch of different derivative rules, and we're looking at the similar questions to the WebAssign question. Pi to the fourth. Pi is just a constant, and raising it to the fourth doesn't change that. It's still a constant, so the derivative constant is just 0. And this is 4 over x to the fourth, which is 4x to the negative 4. And you can take the derivative by bringing out the negative 4 and subtracting 1. And then you bring that across the fraction bar to write it with a positive 5. This one you're going to take derivative of this guy, but you want to write that as 4x to the negative 1 to make it easier. So that's 15x to the second. That's negative 4x to the negative 2. And you write that with a positive 2 in the denominator. This one you're using the product rule. So the first untouched derivative of the second is just 1, plus the second untouched times derivative of the first, which is 2x. Multiply everything out and combine like terms. Number 10 is the quotient rule. So you got the bottom, derivative of the top, minus top, derivative of the bottom, over the bottom squared. And we multiply everything out and combine like terms, and that's what we got there. This one is looks like it's the quotient rule, but you can write that dividing by 10 as multiplying by 1/10. And now it's more like the chain rule. So you bring the 10 out front and subtract 1 from the exponent, followed by the derivative of what's inside. And 1/10 times 10 is nothing, it's just 1. So you just get these guys raised, and this one raised to the 9th. This is your product rule. So you got first derivative of the second plus second derivative of the first, and when you take derivative of the second, you just get 2x. When you take derivative of that, you get 2 times that, and then derivative of what's inside is just a 1. Now if you look at these two larger terms, this one has a 2 and an x minus 1, and this one has a 2 and an x minus 1. If you pull out the 2 and the x minus 1, you're left with just one of the x minus 1s and an x, which is right there. When you pull out a 2 and an x minus 1, you're left with just that guy there. Now when you multiply that out and combine like terms, you get this guy here, and you still have the 2 and the x minus 1. This one, you got bottom derivative of the top minus top derivative of the bottom with bottom squared, quotient rule, but you got to use the chain rule when you take derivative of these guys. So you get 3 times that to the second, derivative of what's inside. And here you just get 2x. And now again, when you want to simplify this, think of this as one large term and this is another large term. They both have x to the second minus 4s. This one has 3 of them, and this one has x squared minus 4 to the second. This one has 2 of them. So you can pull out 2 of those, and they both have a 2x that you can pull out as well. So when you pull out 2 of those and the 2x, you're left with just this guy and that, which is right there. When you pull out a 2x and you pull out 2 of these, you're only left with just one of these left, this guy to the first power. So now you still have what you pulled out front, and what's inside simplifies down to 2x plus 2x squared plus 7. So that's as far as you can go with that. On this one, you can bring the 4 out front and raise it to the third power times the derivative of what's inside. But what's inside is a product. So when you take the derivative of that, you got to use the product rule. Okay, and so you use the product rule, multiply it out, combine like terms, and you get down to here. And everything out front simplifies down. Here, I pulled an x out, but when you pull an x out, it's raised to the third power, so it's x cubed. When you pull an x out, it's no longer x squared and 3x, it's just x and 3. And so you combine those two along with the x squared, and you're left with x to the 11th, and everything else combines like it should. This one, you can write that as 2x times this guy to the 1/2. So you've got the first guy times derivative of the second, which is going to be the chain rule. 1/2 times that to the minus 1/2 times derivative of what's inside, plus the second guy times derivative of the first. All right. So now when you clean this guy up, your 2 and your 1/2 cancel to a 1. You still have the 3. The x and the x squared give you x cubed. And this guy having a negative exponent brings it downstairs, and it's square root instead of 1/2. And this guy is the square root, and it's got a 2 out in front. Now if you want to combine those two, you get a common denominator of this, so you have to multiply this one top and bottom by that number. Now when you do that, when you multiply the square root times itself, you just get the number that's underneath the square root. Anything with the square root times itself gives you just the item under the square root, without the square root. Now you can combine those two, and you get 2x cubed plus 2 plus 3x cubed gives you 5x cubed plus 2. Same denominator. There you go. Alright, this one, they're asking to do 4 different derivatives for things that are very similar. 3 times that to the 5th over 5 is 3/5 times that to the 5th, so now you can just bring the 5 out front, subtract 1 from the exponent, followed by the derivative of what's inside, and then you simplify it. 3 over 5, you can write that as 3/5. You can bring this up top and write it with a negative exponent, and take the derivative like you normally would, and then you can clean it up a little bit. This one is basically just 1/5 times that. You can bring the 5 out front, subtract 1 from the exponent, followed by the derivative of what's inside. This one, you can bring that up front and it becomes negative up top and it becomes negative 5. And then when you take the derivative, you bring the number out front and subtract 1, followed by the derivative of what's inside. They give you the revenue function, ask you to find the marginal revenue. So when you take the derivative of 60,000x, you just get 60,000. When you take the derivative of this, you get the 40,000 out front. You get minus 1 times that to the negative 2 times the derivative of what's inside, which is just a 1. And then minus 4,000, and its derivative of 4,000 is 0. And this one becomes subtraction because of the negative sign there, and that comes down and is squared, positive. Now they ask you to plug in a 10, and you get 59,900, and that's the amount of change in revenue is $59,900 for the 11th camper that is sold. 39, you've got the national consumption. They want to know the marginal propensity to consume, so they're asking you for the derivative of the national consumption function. So you bring the 1/2 out front and subtract 1, followed by the derivative of what's inside. Derivative of 0.4y is just 0.4. Derivative of 4 is 0. And when you simplify that down, you get this guy here. 40, they want to find the rate of change of the price, where the price is here, so you're taking the derivative, and it's the quotient rule. So you got the bottom, untouched, derivative of the top, which is 400 times derivative of that which is 1, minus the top, untouched, times derivative of the bottom, which is 2 times that to the first, times derivative of what's inside, which is 1. All over the bottom, squared. Now if you look at the top 2 larger terms, you can pull an x plus or q plus 2 out. When you pull a q plus 2 out of there, you're still left with one of the q plus 2's and the 400. When you pull out a q plus 2 out of that one, you're left with 2 times 400 times q plus 1, which is going to be 800 q plus 1. And when you simplify that down, well, first you cancel a q plus 1 with a q plus 1 on the bottom, making that a 3, not a 4 now. And whatever is left reduces to this, which finally gives you this final answer there.